Hello, my name is Makabi. I am a student at長岡University of Technology. Today, I would like to talk to you about our study. The title of the presentation is Automatic Selection of Predicates for Common Sense Knowledge Expression. Okay, let's start. First, let me give you some background for our study. To develop an intelligent computer, we not only need grammatical knowledge, but also a large amount of common sense knowledge. For example, in the conversational system, we need some knowledge, such as Pochi is the name of a dog, in order to respond to the user's remark, such as I am suffering from Pochi's biting. To construct such system, many researchers have focused on methods for building a common sense knowledge base and providing accessible representation for using natural language processing tasks. I introduce some related works. In artificial intelligence field, common sense knowledge is also called upper ontology. The upper ontology is an ontology which contains many general concepts. For example, collection of a book has a concept of a type of information bearing objects the form of paper. The sumo and the psych are very famous instance of common sense knowledge. The studies using the upper ontology can exploit a rigorously defined common sense knowledge. For example, their knowledge representation cannot be matched fully with actual expressions. Compared to this, the concept net define the common sense knowledge as some relations are added to sentences or words. For example, capable of relation connects the concept of dog to common sense knowledge, such as walk, sleep, and so on. It is better suited to natural language processing tasks than upper ontology. But for Japanese concept net, the most concepts are collected manually. As a result, coverage of common sense knowledge is exceptionally low. Based on these related works, we aim to automatically construct a Japanese common sense knowledge base that can be utilized for semantic analysis in natural language processing. We define a set of predicates, verb, adjective, and Japanese verbal noun that co-occur with a noun as common sense knowledge. For example, a predicate of back and to train co-occurred with noun of dog. They become the common sense knowledge of dog. As a final goal, we will construct a common sense knowledge base. If we correct common sense knowledge, we can compute the relation between nouns using their common sense knowledge. For example, noun of dog and cat have a similar common sense knowledge, so we can aggregate the concepts as an upper concept of animal based on the similarity of their common sense knowledge. To collect common sense knowledge, we made 3 hypotheses. First, the predicate A is the common sense knowledge of the noun N. When the pair of A and N are frequently co-occurred in sentences, for example, when a noun of elementary school frequently co-occurred in a sentence of I attend elementary school every day, the predicate of attend is the common sense knowledge with a high probability. We sorted the predicate by the number of co-occurring nouns. The list shows the top 10 predicates adding to a noun of elementary school. The predicate placed upper in the list are considered more appropriate as the common sense knowledge. Next, the second hypothesis. The predicate A, which co-occurs with any nouns, is not the appropriate common sense knowledge. What I mean is that when a predicate is a bastile word and co-occurred with many nouns, it is an incorrect predicate as the common sense knowledge. In the example of elementary school, predicate of be and become are frequently co-occurred with noun of elementary school, but cannot characterize the elementary school. And these predicates frequently co-occurred with any other nouns. In this way, we see the predicate which co-occur with many nouns as incorrect predicate as common sense knowledge. So they are deleted. The graph shows the emergency distribution of predicates in the top 1,000 nouns. For example, parts shown by green points, and that's the number of unique predicates which co-occur with 400 nouns is 1,000. If a predicate co-occurs with many nouns, it is found in right side on the graph. We focused on the points which number of predicates is sharply increased. The predicate which fall under the certain scope co-occur with many nouns. So we delete the predicate defined as the deleting predicate. The graph is same as the preceding graph. Sorry, the horizontal axis is reversed. So this area shows the this area shows a sharply increased area. The graph is double logarithmic plot, so the power approximated curve, which means the dramatically increased area, shows us the straight line. We decide the scope of deleting predicate for a list of points on the power approximated curve, the part shown by the red points. For the last, the third hypothesis, whether the predicate A is the correct common sense knowledge or not, it depends on the number of unique nouns which co-occurred with A. What I mean is that the noun which co-occur with many predicates cannot be characterized by generic predicates. Hence, the number of their deleting predicate is more increased than nouns co-occurring with a few predicates. For example, the predicate of run could not characterize the noun of a person which co-occurred with many predicates, but could characterize the runner which co-occurred with only a few predicates. This figure shows the emergency distribution of top n predicates co-occurring with noun. This graph shows the same as the preceding graph. The vertical axis is a logarithmic plot. In the case which a value of n is 100, only the top 100 nouns are taken into account. The rest is disregarded. Comparing both graphs, we decide that the higher ranked noun will have more deleting predicates when nouns are sorted in order of the predicate co-occurrence. Based on the result, we make an investigation of change in deleting predicate while increasing n until there is no more increase. The number of deleting predicates decreases in a staircase pattern, and there are some singular points. We decide the number of deleting predicates for each noun using the singular points. The table shows the number of deleting predicates for each noun. We consider that the 33 predicates are not common sense knowledge and delete from all nouns. We compute a weighted score for predicates co-occurring with noun using Hermann normalized frequency. Predicates appropriate as correct common sense knowledge for a noun when the predicate score is high. We compare our methods to 3 baselines. Baseline 1, we did not delete any predicates, just use the weighted predicate by Hermann normalized frequency. Baseline 2, we do not delete any predicates, just use the weighted predicate by TF-IDF score. Baseline 3, we remove the 427 deleting predicate in n over 700 and use the weighted predicate by Hermann normalized frequency. The table shows the example of assigned predicates adding to doc. Our approach was able to assign the appropriate predicate, but on the other hand, when the baseline 1 and baseline 2 methods, predicates that co-occurred frequently with the many nouns were ranked much higher they were with the proposed method. For example, noun of doc. In the noun of doc, the predicate of become and be that co-occur with many nouns are given higher ranks. Moreover, baseline 3 deleted some appropriate predicates, such as to take out for a walk and bring up. Compared to this, the proposed methods change the number of deleting predicates for each noun, so remain appropriate predicates in ranking. But we could not assign the appropriate predicates in some cases. For example, although a predicate co-occur with a noun many times, they are unrelated pairs because we do not check the dependency relation between them. For solution, we should use only the predicate which depends on the target nouns as candidate of common sense knowledge. In other cases, we could not assign nouns which can also be used as suffix to appropriate predicates. For example, Japanese tsuki have a meaning of moon and month. Sorry, this is a moon and this means a month. Hence, we need to determine the senses. For solution, we should utilize the relation of another co-occurring nouns. For example, if the Japanese tsuki is co-occurred with a noun of sun, it may mean the moon. As a problem, we have included nouns which are used for defining the relation of nouns, such as cause and reason. For solution, we should discuss how we limit the noun of adding target. Conclusion. In this study, we propose a method for statistically selecting common sense knowledge of nouns, utilizing the unique number of co-occurred predicates, and we describe the selection method of appropriate predicate as common sense knowledge for constructing the common sense knowledge base. Then, we evaluated a set of common sense knowledge which are assigned to each noun compared with the 3 baselines, and we demonstrated the assumed characteristics of common sense knowledge in our study. But it is a very subjective evaluation, so for future work, we plan to make a quantitative evaluation. And this concludes my talk today. Thank you for your attention.